I have all the old exams here. Why don't you, let's just pick one. So 2016, 2017, 2014, 2015, 2016. You know what? How many of there are these? 1, 2, 3, 4, 5, 6, 7, 8. Fine. You want to? Huh? All right, well, the random number generator chose 5. 0, 1, 2, 3, 4, 5. 2016, but you want to start with the most recent, which is 2017? Sure. All right, let's try and go through this. No AIDS, remember? So no AIDS. I don't know why I find that so funny, right? In the box beside each piece of code, write its output. If it generate error, say error, and give a reason. Okay, L is a list, 4 elements, item in L. Item is equal to item plus 1, print L. Well, I think that just prints the list. I don't think we've actually done anything. Okay, so let's just confirm all of these things. Maybe I can just do something like this. Is that too small for you guys to read? Okay. So let's give it a try. L's 3, 2, 1, 0. For item in L, item is equal to item plus 1. Print L. Yep, nothing. Okay, easy. L is a list of 4 elements for item in L. Okay, this will have an effect. So we're saying, oh no, this is going to error. For sure it's going to error. It's going to error in its first run, its first iteration, right? It's going to say item is in L, so the first item is what, 10? And then it's going to try to set the 10th position in L to something. So that's just going to error. Ow. I injured my favorite finger yesterday, and I'm really disappointed, because now it really hurts to type. Just wait till you guys like start going up the ladder in terms of learning. Because the Germans count 1 like this. So it always seems like your German professors hate you, right? Print. Wait, how come that didn't error? Oh, yeah, because I didn't hit enter. Okay, so this one's error. Wait, sorry. Which one was on? B? B is an error. L 2, 4, 6, 8. So for item in range, is it? Because item now is appropriately counting, right? So now item is in the range, and the range is going to be 0, 1, 2, 3. So L at 0. Okay, so it's going to set every element is going to be incremented by 1 by the end of this. So the list L should be 3, 5, 7, 9. Agreed? Ow. For item in range, length of L. Ow. L at item is equal to L at item plus 1. So L should be 3, 5, 7, 9. Great. Problems? No? All right. D. All right. Help me stay on track because all these questions look really similar. Is it D? Okay. Okay. Sorry. Was there some difficulty with this? Look, we can all be a little bit noisy today and ask questions. It's sort of like informal. So, like, was there a problem? Yeah. Sure. So you're going to set item to each member of that list L. That's what this like 4 item in L does. So what's the first item equal to? 10. So what happens when you try to access L at 10? It doesn't exist, right? The list L has elements 0, 1, 2, and 3, right? If you ask for the 10th element, it's going to say, I don't have a 10th element, right? Yeah. Okay, D. For L is equal to 5, 6, 7, 8. Who do we appreciate? Thank you. L is equal to, okay, so for item in range, so items counting appropriately. Oh, this is not going to do anything either. It's just going to print L. This is easy. The loop doesn't do anything. 5, 6, 7, 8. For item in range, length of L. Item gets item. A more interesting question is how many times does this loop run? Right? So what will print here? So item will get set to 0, then item will get set to 1, and then 1 will print. And then I think item goes to 1, right? So this should print out the range shifted by 1. Yeah. And of course L, nothing happened to it, right? So like, I don't know. This seems like not a very good question. It's like, here's a, well, I guess you could technically be looking for errors, right? But a couple of these didn't even try to change L, and they're asking you for what happened to L. So hopefully the exam will be this easy. Well, okay, we've only done the first page, so let's pull the reins. Question 2. In the box beside each piece of code, write its output if it would generate error. Okay, so L1 is Tom likes pie. L2 is append somewhat. Print L1, print L2. Okay, so this is, yes. Oh. So what do we get? So I think this is trying to test your like understanding of list pointers. Are you sure? I think both get changed. Who says both get changed? You say. Okay, let's see. Maybe I'll get this one wrong. And it's not a procedure; it's a method now. Now we have the right terminology because a string is a object.
Is there any differentiation between the name of the method that returns something and the name of the method that doesn't?
I don't think so. They're both just methods. Okay, so what's our... I don't know. Okay, so I would have answered this question, L1 and L2 both become Tim likes pie somewhat. But people are telling me that's wrong, so... Okay, so first let's check L1. So L1, I'm sure L1 got appended somewhat, because we gave that instruction. So what should... I don't understand why L2 shouldn't be the same thing then, since we've made them equal.
Because on the, like, at the end of append returns nothing. So it will get set to none.
So append... L1.append... Okay, let's go to the back of the thing and check, right? You're right. Okay, so L2 should be equal to none. Good job, students. You've now surpassed your teacher, which is something that every teacher wants. Okay, good job, good job. So that one was not easy. B. N1 equals 13, N2 equals 13, N2 equals 14. Okay, that's easy. So N1 is 13 and N2 is 14. Should I even run this one through the compiler? Yeah, I don't. Everyone gets this one? Don't try to trick yourself out of like answering easy questions. Right? Don't look at this and be like, "Oh my god, this can't be easy because it's on an exam." Like we are capable of throwing slow balls at you guys. Especially at the beginning of the test, we're trying to bolster your confidence a bit. Moving later on in the test. It's true, it's true. Like I always try to start off a test with like some easier questions, just so you can like imagine the opposite was true. If like I front loaded all the questions with things that were impossible and you guys just like opened the test and like burst into tears. Right? That I've seen that happen before. Maybe you'll see. But you guys don't write in big exam rooms, do you? Do you write in a huge gym or something like that? Someone will cry. Someone will cry, and during your university career, someone will vomit. Those two things I can guarantee. You'll have a crier, and you'll have someone who will vomit. Which one were we on? Okay, X is the list 1, 2. L1 is a list of lists. Dun dun dun. It's technically a square matrix. Okay, so L1 gets... Oh, they're going to... Okay, so L1 should be the matrix 1, 2, 8, 9. L2 should be L1... What happens when we colon? That should just give the whole thing back, right? That's true. Let's
Does that send to the same pointer or to a different pointer?
I don't know. First, let's check this. Yeah, it does give the whole thing back. This is weird though, right? Because slices always create new things, but no, not in a slices of strings will create new things. Slices of lists should be fine.
ID of X and ID of X.
Hold on. Let me just load this stuff in. 1, 2. L1 is X 8 9. Okay, so I know L1 is going to be 1 2 8 9. Okay. So L2 at this point, if I do this, this should make L2 equal to the whole thing of L1. Okay, so now the question is, what has been copied here? The pointer or the... Like, do we have a deep copy or do we have a shallow copy?
It's a deep copy. It's a deep copy.
Because you checked? Oh. Okay, well, L1, L2. That's not what I got. Really? So one of us is wrong. I need someone else needs to check this now. Yeah. Well, the problem here is that we don't know if it had said this, I'm with you, right? But the question now is what happens when we slice a list? Even if we slice the whole thing, does it still return the pointer to it? You got a different one the second time.
When it slices the entire list.
Okay, but okay, I'm gonna exit this and try again, and someone else is going to type this in too to confirm. I'll nominate you at the front, yeah, because you're in striking distance. Okay, so let's try again. Whoops. And everyone make sure they're in Python 3. 1 2. L1 is X 8 9. L2 is L1. And you claim that's a deep copy, but I think this is a shallow copy.
I found out what it is. You're modifying X, and X is a shallow copy. Everything else is a deep copy.
I see. That was a tough one. Because remember, this is a list of lists. So like the outside stuff is a shallow copy. And the inside lists... Oh, sorry, the outside stuff is a deep copy, and the inside stuff is a shallow copy. Right, so this is actually an instruction to append to X. And X is in two places. Okay. So watch, if I were to say X.append 5, it's going to add that to both lists as well. Because both lists just have a shallow copy of X. I shouldn't have complained that the test was too easy at first. Now I regret it. Okay, part D. I create a function called f. It seems to just multiply its input by 2. I have a pet, it's a dog. So if I call f of pet, yeah, it should be dog and then cat cat. Okay, so first of all, remember that we can multiply strings by numbers, right? And now you know, like, at some point, some programmer made a decision that the mixed arithmetic objects here should result in this. Except I think they were allowed to do this. I wish I was allowed to do that. Okay, let's run this one through, just to make sure. F of pet. Okay. Print pet. Dog. Print F of cat. Cat cat. Great. Yes.
In this case, will we have to write that f of pet prints dog dog?
Yeah, hold on. Let me think.
not on the console. It's just like on the.
Yeah, I think, okay, for our test, yes. For this test, I think maybe the professor said just worry about the stuff that I'm printing.
For our test, do say dot.
In your test, the beginning of the test says something like, assume the following has been inputted into the Python interpreter. What would the screen show or something like that? Yeah.
And should we do dot with quotes and everything else without quotes?
That would be the most correct, but we're not going to deduct marks for printing a string with quotes. Even though you should print a string without quotes. That is the most correct. And maybe we should be deducting marks, because maybe next term they will. Right? But at the time being, I'm just concerned about writing things that are correct. We'll start hitting you on details later. Okay. In Canada, Canada, the federal and provincial governments use a progressive tax system. They sure do. For many Canadians, this means that when their income goes up, their tax rate goes up too. Marginal income tax rates are used when determining the total amount of tax due. The 2016 federal marginal income tax rate in Canada, I'm already bored, are given in the following table. We have 5 brackets. So if you make up to $45,282, you'll be taxed at 15%. The tax rates are higher than this, for sure. Okay, so I imagine they want us to write a program that calculates someone's... Jeez. I would not make you guys read this much stuff on a test. I can't find a right balance. Is this blurry for you guys? Blurry for me. Okay, so for an income of $12,345, the marginal tax rate is 15 cents. And for an income, if the marginal tax rate is 0.25. Return the 2016 federal marginal tax rate in Canada for income. Get marginal tax for 0. Oh, this is easy. All they want us to do is return the percentage, right? So you just basically have to write an if statement to find out which of these brackets it falls into. It's a lot of reading for something that's this simple. Okay, that shouldn't be hard at all. Get marginal. Okay, I'm just going to say get marginal tax rate. Right? Income. Okay, if okay, so what are the okay, so if income is between 0 and wait, is it inclusive or exclusive?
It says up to, so it sounds like
Okay, 45282. Return 0.15. I don't even need an elif because it will have escaped by now if it triggered, right? So I'm just gonna keep. Okay, so everyone heard? I just said I don't really need an else because if this if statement triggered, then it would have returned. So okay, so the next one, if we have to be greater than 45,282 and less than or equal to 90,563. 205. I'm not going to do the rest of this. Okay, so the one thing that you should take from this is remember that you can do these double-sided brackets for ranges. So let's just give it a try. 1, 4, 5, 2, 8, 3. Okay, great. The hardest part of this question was not falling asleep while reading it. I'm shocked that the answer to this question was that easy after all of that setup. Oh, there is more stuff though. So, okay. Add more test cases. Do not duplicate test cases. Okay, so this is now more... Okay, so this question isn't about writing code. Right? So I should have read the question, but it's just so long. So they actually just want us to write They want us to write the test cases for this. So what are like the best test cases to pick? Zero. Well, so like we have intervals, right? So you want to choose all of the like literal border cases of those intervals. What would be the ones I choose? How many do they want? What? Okay, well, how many brackets do we have? 1, 2, 3, 4, 5. So there are 5 brackets, which means there are 1, 2, 3, 4 things in the middle, plus 5 on the end. So that's 9 edge cases that we can get. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4. Okay, all the edge cases, and then 4 things inside is what they want. But that is a lot of that's a lot of tests that they want. How many was this worth? 4. Okay, we have asked something similar on your exam, except the way that we stated it was, here's a function, write 4 docstring examples. Right, you guys are used to writing. You guys know what a docstring example is, right? Okay, so we didn't give you a table. We just said outright, write 4 docstrings examples for the following algorithm. Question 4. Complete the body of this function according to its docstring description. Separate and reverse vowels. Return a list containing 2 strings made up from the characters in S. The first string contains all of the characters in S that are vowels, in order opposite to how they appear in S. The second string contains all of the other characters. No problem. I'm just going to call all of my things foo. 3, 4, 5. Okay, so what do we need to do? We need the 2 strings made up of all the characters. So we have 2 answers. One of them is for the vowels, which I'm going to make empty. Another one is for, I'm going to regret doing this in the terminal. What's the other one? Consts. For, I want to call that S's. Okay. Okay, so if X is in a vowel, A, E, I, O, U, A, E, I, O, U, then I have to append to vowels from the left, right? Is it the left? Yeah, this will reverse it. Else, come on, consts is equal to consts plus X, right? So for the one I'm like appending on the left, and for the other one I'm appending on the right, and because one of them has to come back reversed. And then return, what am I returning? A list? Yeah. Which one first? Vowels? Consts. No! All right, I'm not going to do that again. I'm going to go out here. All right, so let me just grab this and see. Oh, I can't grab that. Boo! X's. I had what? Vowels was empty. Constants were empty for X in X's. If X is in a vowel, A, E, I, O, U, A, E, I, O, U. And then vowels gets added from the left. Else, consonants gets consonants from the right. So this should work. Return, right. Vowels, consonants. There's not many vowels, but let's see. Is that correct? Oh, were we supposed to keep the space? I guess we keep spaces. Yeah, we keep spaces. I guess all punctuation, well, I guess all non-vowels would go to the other thing. This is when Piazzi would be like, well, what about punctuation? Is punctuation a non-vowel? Yeah? Oh, okay. All right. Yeah, next year if I teach this class, I'm going to have a whole lecture on what it means to match a pattern, right? And how not to figure out that you didn't match it. You guys know what regular expressions are yet? Soon. Write a formula in terms of k, where k is the length of s, that describes the number of comparisons made. Oh, okay. That's interesting. So going back here, what's the complexity of the algorithm? Basically is what they're asking. Well, specifically, they're asking how many comparisons are made. So first, isolate any of the comparisons. I don't know, but let's work towards it. Hopefully, you'll be right. So where's the comparison made in this program? What line? Well, the whole thing's a for loop, so be more specific, right? Line 6. Do you see that there's a comparison happening in line 6? It's asking if x is equal to any of those vowels. So line 6 actually does how many comparisons? A, E, I, O, U? 10. 10 comparisons happen on line 6. If there is a list of length n, or what did they say, k? Length k. So if there's a list of length k, that means we're going to do 10 comparisons for each member of k. So we're going to have a complexity of 10k, which we've learned is just k, because we don't like constants, because we don't care about constants, which means you're correct, but you should be, if you would have said n, you would be wrong, right? Because we have to be careful. They said the length of the list is k. Yeah, sure, yes, I trust you, but if you were to write O of n on the test, you'd be wrong, yeah. I think they want 10k here, right? Because they want a formula in terms of k. They don't want the order of it, right? So I think writing O of k would be wrong in this case. They really want because like that one we can get the exact number of comparisons made, right? We don't have to bound it. I know exactly how many iterations that each thing will take. So this should be 10k. Yes?
It says A and B counts as one comparison.
Oh, okay, then k, right? Yeah.
If we write the function with list notation, like list comprehension.
This one?
Determine the
Don't. Don't make life harder on yourself, right?
How would you determine the time?
Well, you'd have to unpack it into what, like, you'd say this is a list comprehension equivalent to this embedded for loop, right? You'd have to unpack it, right? So, like, that's the downside of coding cryptically, right? Is that the complexities are a lot more hard to suss out, right? Just wait till you have to do it with recursion and stuff that's like non-deterministic. Get crazy. What next? Which of the following best describes the running time? Is it constant? Linear. It's linear, yeah? Okay. I don't know if we gave you a complexity question on your exam. Let me just pull it up. None of you threw up your hands to say stop. Okay, let's read this other beast of a question. I would never make you guys... If I wrote an exam, this would be all the letters I'd use on the exam. This is a crazy amount of stuff to make you read. A run is a non-decreasing sequence of integers. Okay, so non-decreasing. So it can be increasing or steady. I guess what non-decreasing means. For example, the sequence 366 is a run, but the sequence 21 is not. Okay, because 21 has decreased. A non-decreasing sequence of integers is a sequence or list of integers where each term in the sequence is not smaller than the... Okay, I get it. Non-decreasing. They explained it 3 times, right? I know what it means. Maybe you don't know what it means, but it certainly frustrated me. Follow the function design recipe. Nah. That you have learned in this course. The order of Just ask me the goddamn question. For example, if you're... then your function would return. Takes a list of integers and returns a list that contains the starting index of each run within the given list. Okay. Okay. Did everyone read that? So read it. Because, like, reading and apparently understanding what it is they want from you is going to require some thought. So who can explain to me in a different way what it is they want for, right, in this? Yeah.
Do they want the index is where like you can get the increasing part? So like the first part where it's increasing is from 3 to 5, but then it's 1, so it stops and it just on 0, then it goes to the 5, it checks 5.
Yeah, you're describing an algorithm to how to get it, but like, can you give me an English statement for like what it is they want us to calculate?
He wants you to get the index of the first number in every row.
Yes. Yeah. So there are consecutive sublists of this list, some of which are non-decreasing, and the algorithm wants us to return the starting index of all runs, right? So what do we want? Non-decreasing. Okay, so if they give us 3 and 3, 5, 1, 2, 2, then 3, then 5 is a non-decreasing sequence. Okay. So we should return 0. And do we not return 1? Has to be... Okay, so it has to be a... Oh, so we go over this then to the next one. Right, okay, so here's a non-decreasing sequence. And then it ceases to be non-decreasing. And then we look at 1 to 2 to 2. That's also non-decreasing. Okay, so we have a non-decreasing sequence starting at 0, starting at 2, and then starting at 5. Okay, so they basically want us to like cut the list so that like the individual cuts are like non-decreasing lists, right? And the indices are like where the cuts should happen. Is this the last question? Nope. Okay, how do you want to do this one? Oh, it's easy. It's easy. Yeah. Pardon me? Yeah, but so this is how you look at it. You like you go through the list and you say this is a non-decreasing sequence, and then you cut it here, right? And then you say this is a non-decreasing sequence and cut it here. Right? So like technically 5 is also like every position in itself is a non-decreasing sequence of length 1. Okay, I'll write it on the board. 3, 5, 1, 2, 2. Okay, so like this is a non-decreasing sequence. Yeah? This is a non-decreasing sequence. And this is a non-decreasing sequence. That's also a non-decreasing sequence, but these are the longest ones that we could find. Right? The question's not asking us to give the indices for all starts of non-decreasing sequences. They're saying, find the longest, like find it, and then say, okay, like cut it here. And then find the next longest one and then cut it. Right? And then find the next one. Right? So if after this list was like 2, 3, 4, then you'd have this. Right? They don't want us to say this is a non-decreasing sequence and this is a non-decreasing sequence and this is a non-decreasing sequence and this is a non-decreasing sequence. Right? They want us to find these divisions that I wrote on the board. Okay, so I think this one should be not bad, right? Because we just have to walk the list and monitor if we're non-decreasing. And every time we violate the fact that it's non-decreasing, we should just append that to the list. Okay. Maybe you guys will want these, so I'll change this to bar 0. What am I taking? A list of integers. And I'm returning what? A list of integers again. I don't want to call typing. All right, so I have to monitor non-decreasingness, which means now I need a counting variable. I need an index variable. So for k in range length of x's, minus 1, right? Because whenever I'm comparing two positions, I either have to start at 1 or stop at 1 less than. Okay, so I want to compare. Okay, so I have an answer. It contains nothing. If it is the case that x's at k plus 1 is... Okay, what's the violating condition?
Less than.
Is it less than? Jeez, no, we're non-increasing.
It should be less than. So the next
Yeah, now, okay, so this should be x of k, yeah? Okay, this is when we fail, right? Condition fails. Okay. Not non-increasing. Jesus. Answer gets appended. Okay, so now I'm confused. Do I append k or k plus 1? Huh?
And the starting of
I think it's k plus 1. Because I violate at... No, it's k. Let's see if this works.
But wouldn't that return position number 3 for the second one? It would go like 3, 5, but then it would go like 1, 2, then 1, 2.
Well, okay, let's remember the list indexes here, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 3 is less. So I'm looking for when this number is less than this number. So that's not violated, but this is violated. So I have to put 1 into the list, right?
Yeah, but you're supposed to put 0 here.
I'm supposed to put... Oh, I have to put the beginning of the list. That makes things a little bit harder. Wait, okay, but hold on. What happens if I have all of... Okay, so suppose I generate my solution. How do I just have to shift everything back, right? Right, so if my solution returns 2, okay, 4, and then I guess this should have been 5, right? All I have to do is subtract 2 from everything. Just I'll pull everything back. And I get 0, 2, and 3. The first position gives you the offset of everything. Okay, you're saying I chose 2 and it should be 0. I'm saying you're right. So I'm going to take 2 to 0. I'm going to take my 4 to 2. And 5 to 4. Okay, I'll show you that it works first. Did my explanation make sense to anyone? No. Okay, well, first I'll prove that it works. So then I want to do return. I'm going to do a list comprehension. I want to do a minus a0 for a and answer. Okay. Did I spell append wrong? Yes, I did. So what was the one I wrote on the board? Something's weird's happening with my fonts. 3, 5, 1, 2, 2, 1, 2, 3, 4. What is... Oh. Int object is not subscriptable. Oops. Oh, I guess I should always append the last k. It'll be pulled back. Or k minus 1. Okay, try to break my function. Yeah.
Shouldn't you just append the 0 position first? Because that's always going to be wrong.
Yeah, but I'm doing it differently, right? Because originally I said, let's find these divisions. And then someone said, look, you're not supposed to find the right endpoint. You're supposed to find the left endpoint. And I'm saying, well, I just found the right one, so I'm just going to shift them so they'll all be the left ones. Right, so we could do what you did and find all the left endpoints, but I don't know how we're gonna have to store something. right? So like, go ahead and write it the other way as well. That's good practice. But I think my original method of just remembering where the condition was broken and then shifting everything is the most simple way of answering this, right? Because how you're gonna have to remember the last position, like you're gonna have to remember all the starting runs and then test for violation, then put that in the list and then move. Anyways, I like my answer better, but prove to me that it maybe is crap. Give me some edge cases.
Maybe you can do the original one. Maybe 5, 1, 2, 2, 1.
Oh. So it is broken. Yes. I'm supposed to subtract the previous one. Yeah, you're right. Why didn't it just work? Okay, well, let me first see that what I'm actually getting back. So I'm getting, okay, those are already wrong. Oh no, these are the right endpoints, yeah. 1 and 4. So how come why didn't I get the end here? Oh, the end will always be an endpoint. The last element of the list is always going to be, yeah.
If something has like 1, 2, 3, 4, the end is not going to be the endpoint, it's going to be the part of the bigger chain. So like
That's right.
There's situations where like the endpoint is not the end.
All right, so clearly I had to think about this better. So let's do it a different way then. Let's do it the way that you recommended. Okay, so we have to find the left endpoints then. So for k in range length of x's. Okay, so what's the condition okay, I'm going to start from 1 then. No, I still should start from 0 and go to 1 minus the end. Okay, so I don't know, help me out then. What am I supposed to do?
Well, I was thinking maybe creating like a pointer and then like checking where like the first. Well, you know the first variable will always be like the list, so like always.
Okay, hold on. I'm going to say answer is originally 0. So I'm going to use answer to store the, no, left endpoint. I'm just going to say this. Left endpoint is 0. Okay. So if x is at k, how do I violate the condition again? Has to be bigger than x is at k plus 1. Then I have to put the left endpoint into answer. And left endpoint now becomes where I'm standing now, plus 1. All right, what does this return? Is that closer? 0, 2, but we're missing what? The last one. How come I'm missing the last one? I think I can fix this by doing this. I have to be non-decreasing. -1? I think float inf would be better. Because they never gave us a... I think you're assuming that the integers are always going to be positive, which was never actually stipulated. Was it? Integers. Integers can be negative. Yeah. That worked. Wait, did it? No, shouldn't 5 be 4? Is it 5? Great. Okay, give me another one. And how much time? Oh, we're done. Okay, give me another one.
The one you use 3, 5, 1, 2, 2, 1, 2, 3, 4.
Great. Okay, no, but we want to violate again. So 1, 2, 1, 4, 7. Yeah, it seems to work. Oh, 8. Yeah, this is a good one to test. What happens if the whole thing is decreasing? Great. Okay. We didn't get through the whole thing today, but that's okay. Because the whole thing is a decreasing list. So you're never going to get any non-increasing, right?
Oh.
Yeah.
But so if it's decreasing, should return every index.
I believe so, yeah. Oh, this is a matrix question. You guys, I think there's definitely a list of list question on your exam, right? So maybe you should try this one. Anyways, you guys go. Good luck on any tests that you have. Remember, we still have next week, Monday and Wednesday, to do more exams, right? So also bring questions, huh? Tuesday, Wednesday, sorry. You're the section 1. Right? Other section is Monday, Wednesday. Yeah.